Welcome to the next session, my dear friends. In the previous session we have completed all the theoretical part of air pollution and noise pollution. Now we are doing the previous gate questions of air and noise pollution. So let us start with the first question. So 10.2, air and noise pollution. Air and noise pollution. So question number 1, GATE 2008 1 mark. Two primary air pollutants are, so they have given 4 options in that primary air pollutants. So for option A is sulfur dioxide and ozone, and option B nitrogen oxide and peroxyacetyl nitrate PAN, and third option is sulfur oxide and hydrocarbon, and fourth option is ozone and peroxyacetyl nitrate. So here it is clear that the primary pollutants are SOx, NOx, carbon monoxide, hydrocarbons. So likewise I have given some list of primary pollutants. So in that, if you see the options, so hydrocarbons are there and sulfur dioxide or sulfur oxide is there. So this and this both are primary pollutants. That is a suitable answer from the given options. So option C is the answer. So next question, question number 2, GATE 2011. GATE 2011, 1 mark question. Question number 2. Question number 2. Question number 2. Consider 4 common air pollutants found in urban environment: NO, SO2, soot and O3. Among these, which are secondary air pollutants? See, it is clear that NO and SO2 are primary pollutants. So they are primary pollutants. So these are primary pollutants. So remove them. So soot and O3. So we are having 2 more air pollutants. So here it is not soot, it is SO2. Okay, SO2 is there, and NO2 is there. So what are the options given? So we know that O3 is not primary air pollutant, O3 is a secondary air pollutant. So this soot, whatever the SOOT soot, is not the secondary air pollutant, it is primary air pollutant. Soot is nothing but the impure unburnt carbon. So here soot is nothing but unburnt carbon. So the smoke which is coming out of the chimneys, unburnt carbon, that is nothing but soot. So this is also primary air pollutant only. So O3 is secondary air pollutant. And next question, question number 3, GATE 2015, GATE 2015, 1 mark set 2. So the question is SO2 and CO adversely affect. So SO2 and CO, so the effects of SO2 and CO both affects the respiratory system, so by causing some kind of irritation and inflammation kind of symptoms. So here if you look at the answers, so SO2 SO2 and CO both affects the respiratory system. So SO2 will react with the mucous membrane. That means it will cause irritation in the mucous membrane, and it causes some kind of respiratory issues. As well as if you see the carbon monoxide, it reacts with the hemoglobin and forms carboxyhemoglobin. So because of which the oxygen availability inside the blood will reduces. So because of which you feel breathlessness due to the formation of carboxyhemoglobin. So both will affect the respirations. If you look at the first option, oxygen carrying capacity of the blood will be reduced by carbon monoxide, because carbon monoxide reacts with hemoglobin. So that hemoglobin content will reduces in the blood, because of which the oxygen carrying capacity of the blood will get affected, because that means carbon monoxide effect is oxygen carrying capacity. If you look at that, the C option, it looks good. That means SO2 affects the respiratory system and CO affects the oxygen carrying capacity of the blood respectively. That is the answer of the third question. So the fourth question, GATE 2016, 1 mark. GATE 2016, 1 mark, set 1. Question number 4. Precursors of two photochemical oxidants are. See, photochemical oxidants, that means PAN, PPN, BPN. So all these things will be formed. So PAN, PBN and PPN. So all these things will form when on the reaction side, if you are having nitrates. Okay, first of all, NOx is needed, plus photosynthesis, that means photoelectric energy. Photon energy is needed, and unburned carbon is needed. Unburned, these are peroxyacetyl, peroxybutyrenyl, peroxyperenyl. So these are all nothing but carbon compounds. So unburned carbon compounds should be present in the nature. That means I told you already, whenever there is a stack, from the stack the smoke is coming out. Smoke is nothing but it contains unburnt carbon. Okay, so unburnt carbon is present, and along with that this NOx is present there in the nature, and humidity is present, and energy is present, sunlight is present. Then the secondary pollutants will form. These are the basic requirements. These are the precursors. That means what are the products, what are the reactants needed is the question. So NOx, sunlight and unburnt carbon, that means that is nothing but volatile organic compound. It is nothing but volatile organic compound. So this unburnt carbon is nothing but volatile organic carbon, that is VOC. So these three are needed, 1 and 2 and 3. Okay, sunlight, NOx and VOCs are needed for the formation of photochemical oxidants. So the next question is question number 5, 2016, 1 mark, set 2. Question number 5. The atmospheric layer closest to the earth surface. It's a very simple question. What is the closest layer to the earth surface? So we are having 4 layers. Out of the 4 layers, troposphere is the closest layer. The closest layer is troposphere is the answer. So option number D is the answer. Question number 6, 2017, 1 mark, set 1. Question number 6. Acid rain. Which of the following is not present in the acid rain? Generally acid rain is formed due to NOx, SOx and CO3 2 minus emissions. So generally these are the anions. So carbon compounds does not cause any kind of acid rains. Inorganic compounds such as NOx, SOx, CO3 2 minus, these things will form, it will form HNO3 acid, so nitric acid, it forms H2SO4 acid and it forms H2CO3 acid, and if Cl minus is present it forms HCl acid. So these kind of acids will form, these are all inorganic in nature. So here acetic acid CH3COOH is not the answer. It does not cause any kind of acid rain. It is a carbon compound. Okay, so that is wrong. That is wrong. So sixth D option is wrong. And seventh question, GATE 2019. GATE 2019, 1 mark set 1. 1 mark set 1. Seventh question. Which one of the following is a secondary pollutant? Many times the same question is coming again and again. Carbon monoxide is primary, hydrocarbon is primary, unburnt carbon itself is a primary pollutant only. It is also a primary pollutant, and this is another primary pollutant. They forms secondary pollutant. So carbon is also a primary pollutant. The smoke which contains unburnt carbon is also a pollutant. So that is why here VOCs and carbon monoxide, hydrocarbon all are primary pollutants. Only ozone is secondary pollutant. O3 is secondary pollutant. Okay. Same question has repeated 2011 after 2019, just 1 year before. Which are the following? Question number 8, 2019 again, 1 mark, set 2. Question number 8. Which one of the following contains only primary air pollutants? So the 4 options are given. They have asked what are the primary air which options have only primary air pollutant. So first option is having hydrocarbon and ozone. So ozone is not primary pollutant. So remove that option A. Option B is ozone and PAN. So PAN is not primary pollutant. So remove option B. And also ozone is also not a primary pollutant. So option B is also ruled out. Option C, hydrocarbons and nitrogen oxides. It is correct because hydrocarbons and nitrogen oxides both are primary pollutants. Hydrocarbons and nitrogen oxides are both are primary pollutants. And fourth option is nitrogen oxides and PAN, which is wrong. So option C is the answer. Eighth option C is the answer. So ninth question, GATE 1991. These are all small questions are there. All are 1 mark questions. So if you are having a basic knowledge about what we have discussed in our class, so we can easily solve all the questions, majority of the questions, because I told you in the beginning, air pollution topic is not a small topic. It has no bar. Anything can be asked in the air pollution. So that is why, so far we have discussed from these concepts, majority of the questions can be solved. So next question, 1991. One more question number 9. So in an atmosphere under superadiabatic lapse rate, superadiabatic lapse rate means what? Environment lapse rate is greater than adiabatic lapse rate. In this case, what kind of the emission from a chimney produces plume described as? If you see the plume rise models, you will know. So that is looping plume. So that is looping plume. When the adiabatic lapse rate is less than environmental lapse rate, you will be having looping plume. So the looping plume will be like this. So we need to by heart all these Coulomb-Rice models and their conditions. That is also important for the exam, but long back it was asked in 1991. After that, in very few instances it was asked, so keep some less priority to that. If it is asked in the latest examinations, we can remember that again. So question number 10, GATE 1993, 1 mark. GATE 1993. During temperature inversion, atmosphere, air pollutants tend to. So during temperature inversion, what happens? Air pollutants accumulate above inversion layer, accumulate below inversion layer, disperse laterally, disperse vertically. Generally when it is a inversion layer, so the pollutant cannot cross the inversion layer. The pollutant cannot cross the inversion layer, so that is why it will accumulate below the inversion layer. So inversion layer means what? So temperature is decreasing downwards. So the inversion means, so generally temperature should decrease upwards, the temperature is decreasing downwards. This is called inversion. So when you are coming down, the temperature is decreasing. Temperature is decreasing, that is called inversion. So that means in that case, when it is rising up, that is becoming, the temperature is what happening when it is altitude is rising, temperature is increasing. So because of which always the environment will be lighter, pollution parcel will be warmer, pollution parcel will be cooler and heavier. That is always the pollution parcel cannot cross this inversion layer. Okay, so that means it accumulates below the inversion layer. It accumulates That is the answer of the question number 10. Next is question number 11. GATE 2007, 1 mark. Question number 11. So the dispersion of the pollutants in atmosphere is maximum. So the dispersion will be maximum when superadiabatic lapse rate takes place. So when the superadiabatic lapse rate takes place, then the pollutant can be easily escapes. Dispersion will be maximum. That means environmental lapse rate is greater than adiabatic lapse rate. The answer is environmental lapse rate should be greater than adiabatic lapse rate. That is the answer of question number 11. Question number 12, GATE 2009, 2 marks. GATE question number 12. So the question is like choose the following, match the following. So list 1 and list 2, and here A, Coriolis effect. Coriolis effect, and option B, fumigation. And option C, ozone layer. And D, maximum mining depth. Maximum mining depth. And on the other side, 1, 2, 3, 4, 1 is rotation of earth. One is rotation of earth, and second one is lapse rate and vertical temperature profile. Lapse rate and third statement, inversion, and fourth one is Dobson. So now, if you know some options, that means if you know some values, then we can find the other. So you might learned this Coriolis effect in the hydrology topic. So in hydrology, the cyclones and anticyclones, why the cyclones in the northern hemisphere is anti-clockwise direction, why the cyclones are in clockwise direction in the southern hemisphere. So all these things are dependent on the Coriolis effect, that is rotation of the earth. That is rotation of earth. You might have studied this in your hydrology topic. So that means this Coriolis effect is related to rotation of the earth. That is the first one which we know. And fumigation, we generally observe this plume when there is inversion. Fumigating plume, we will observe generally if there is inversion in the environmental lapse rate. So these two things we know. So ozone layer measurement, generally we do ozone layer measurement in Dobson. Okay, this you need to remember by heart. This is a standard bit only. So ozone layer we measure using Dobson unit. So three things we know. Obviously the fourth one, maximum mining depth, is dependent on the lapse rate and vertical temperature profile. Okay, so otherwise if you don't consider it, generally during mining, so it is all of them, the mining is anaerobic decomposition of the organic matter, because of which heavy methane reserves will be present inside the mining area. So if you don't consider this lapse rate and vertical temperature profile, what happens? Methane gas evolves and explodes. It causes fatality of the mining people. So that is why generally we take care of this maximum mining depth using this lapse rate and vertical temperature profile. So from this we can conclude that A is 1 and B is 3 and C is 4 and D is 2. So 1342 is the answer. So 1342 is the answer. So let us see where is it. So option number D is the answer. Option number D for the question number 12. Yeah. So let us go to the next question, question number 13. Question number 13, GATE 2010. One mark. An air parcel having 40 degrees temperature moves from ground level to 500 meter elevation in dry air. The following adiabatic lapse rate. Following the adiabatic lapse rate, the resulting temperature in the air parcel at 500 meter elevation will be. So we all know for 100 meter rise, so it will lose 1 degree centigrade. So here it is rising 500 meter, so it will lose 5 degrees centigrade approximately. So if it is 40 degrees centigrade, then at 500 meter, so it will be approximately 35 degrees centigrade. It will be approximately 35 degrees centigrade. That will be the answer. So 13th, A is the answer. Okay. So adiabatic lapse rate is, so 100 meter rise, 1 degree is the reduction in the temperature. That is nothing but adiabatic lapse rate. So that is question number 13. Question number 14. Question number 14, a little lengthy question. Let us do it clearly. GATE 2011, 2 marks. So total suspended particulate matter TSP of concentration in ambient air is to be measured using high volume sampler. The filter used for this purpose, initial dry weight is 9.787 kg. The filter was mounted in a sampler and the initial airflow rate of the filter was set at 1.5 meter cube per minute. Sampling continued for 24 hours. The airflow after 24 hours was measured 1.4 meter cube per minute. The dry weight of the filter paper after 24 hour sampling was 10.283. Assuming a linear decline in the airflow rate during the sampling, what is the 24-hour average? Okay, so here he is asking, the given data is initial dry weight of filter paper, or the filter is 9.787 grams, 9.787 grams, and after sampling the weight is 10.283 grams. Initial rate of flow, initial flow rate 1.5 meter cube per minute, and after 24 hours it is 1.4 meter cube per minute. So which is linearly declined. It is declined linearly. Okay. Now, so what is the concentration of TSP? What is the concentration of the TSP? So what is the average air flow rate? Average air flow rate is equal to 1.5 plus 1.4 by 2, because it is linearly varying. That means it is equal to 1.45 meter cube per minute. So this is the rate of flow, average rate of flow. With this rate of flow, we have sent the air for 24 hours. So volume of air sent. So what is the volume of air sampled? Volume of air sampled is equal to, so 1.45 meter cube per minute into how many minutes? 60 minutes and 24 hours. So this is the total amount of volume of air sampled, which is equal to 2088 meter cube, which is equal to 2088 meter cube. So the TSP is nothing but final weight minus initial by volume of air sampled, that is V, volume of air sampled into 100. Okay, we need to find this. He is asking to find this in microgram per meter cube. So it was asked us to find it in microgram per meter cube. So 10.283 minus 9.787 by 2088, this is meter cube, and this is gram. So microgram means 10 to the power of 6 microgram into 100. Okay, 10 to the power of 6 microgram into 100. So by solving this, we will get it as 237.5 microgram per meter cube. 237.5 microgram per meter cube. That is question number 14. So next is question number 15. GATE 2013, 2 marks. Question number 15. Elevation and temperature data for places are tabulated below. Elevation 4 meter, temperature 21.25, and elevation 444, temperature is 15.7. Based on the data, the lapse rate can be referred as the lapse rate. Simply it is ELR. So elevation and temperature 4 and 444. Okay, 4 and 444. Temperature was 21.25. So degree centigrade, 21.25 and 15.7. The lapse rate is nothing but, the ELR is nothing but dt by dz. That is 21.25 or minus dt, minus 15.7 by 400. So if you solve this, you will get the value as 2.67 degrees centigrade. So minus 2.67 degrees centigrade. This is ELR. So ELR is minus 9.8 degrees centigrade. So ELR is greater than ELR. So minus 9.8 is lesser value. Lapse is more. It is reducing by. So here lapse rate is more than natural. So this is referred as superadiabatic lapse rate. Okay. So that means this is called superadiabatic. This is not, ALR is less than ELR. Okay. This is called superadiabatic. That means here if you see, 1 second. So the lapse rate here is 2.67, 21.25 at the ground if you take the temperature at the 4 meter elevation. So both air parcel and pollution parcel. At 444 meters, that means 400 meters. At 400 meters it is becoming 21.25. It is becoming 21.25 minus 2.67. But this is becoming 21.25 minus 4 times of 1 degree, that is 4 degree. So 4 degree is reducing. For every 100 meter 1 degree. So 400 meter 4 degree. So here its temperature is more, its temperature is less. Its temperature is more, its temperature is less. So that is not superadiabatic process. That is not superadiabatic lapse rate. This is not superadiabatic lapse rate. What are the options given? So it is subadiabatic lapse rate. Elevation number data for places are tabulated below. Lapse rate can be referred as. This is not superadiabatic because always adiabatic lapse rate is constant, that is 9.8 per kilometer. But here whatever the change, that is environmental lapse rate. It should be subadiabatic lapse rate, not superadiabatic. ALR, adiabatic lapse is more. Okay, ALR is more than ELR. So this is subadiabatic lapse rate, not superadiabatic lapse rate. That is question number 15. So question number 16. (2017) 1 mark. Sector 2. following observations have been made for the elevation and temperature to ascertain the stability of the atmosphere. The atmosphere is classified as. So this is the stability. Okay, elevation was given and temperature was given for an atmosphere. So elevation in meter and temperature in degrees centigrade. So elevation is 10, 60 and 130, and the temperature is 15.5, 15 and 14.3. So the atmosphere is classified as, if you plot this on a graph, if you look at this on a graph, so here 10th meter, 60th meter and 130 meter. So here at the 10th meter it is 15.5. Somewhere here let us take this is 15.5, and at 60th meter it is becoming 15. So let us assume this is 15. So it is moving like this, and 130th meter it is again becoming 14.3. So it is further reducing like this. So here the temperature is reducing. Let us just have a slope of it. What is the lapse? What is the lapse in it? Okay, so it is 0.5 lapse, dt is 0.5 and dz is 50. So it is having a lapse of how much? 0.5 degrees for 50 meters. For 100 meters it is 1 degree. So that means normal lapse. So 100 degrees it is 1 degree. If you see this here 60 to 70, again here 0.7, that is 1 degree. For every 100 meters it is 1 degree lapse. So it is neutral. So if you look at this, so 100 degrees 1 degree centigrade is the lapse. That means it is nothing but the adiabatic lapse rate. So if the environment lapse rate is also same as adiabatic lapse rate, then we call that condition as neutral condition. So here it was given as unstable, which is wrong actually. Okay. 15 minus 15, 0.5 by 50. How much it is? 5 by 500. Okay. 5 by 500 meters. For 100 meters, no, it is normal lapse only. See here, dt by dz is 1 degree centigrade, okay, for every 100 meter. This is normal lapse. Okay. So this is nothing but 0.01 degree centigrade only. If you see here also, this is 0.01. This is normal lapse only. It is neutral. The answer is neutral, not unstable. That is wrong answer. The answer is neutral. Neutral is correct. Question number 17. It is again the Plume-Rice models. Oh, sorry, not Plume-Rice model. 2000. Question number 17. Yeah. Question number 17 is GATE 2018 1 mark. GATE 2018 1 mark. So it is just different plume rise models and their conditions are given. So list 1, the condition, and list 2 or group 2 is group 1. So in group 1 and group 2, so group 1, P super adiabatic, so it is super adiabatic. So Q, option Q, it is adiabatic. It is neutral. And PQR, inversion. And S, inversion over super adiabatic. Inversion over super adiabatic. And in group 2, first plume is looping plume. Coning plume. This is looping. Coning. Next is fanning. Fanning, and last one is fumigating. Fumigating plume. So these are the conditions given. So we know that this looping plume, so we will observe the looping plume when there is super adiabatic. So super adiabatic condition, so this is looping plume. Okay, so in super adiabatic we will be having looping plume, and adiabatic, in adiabatic condition, let us keep it aside. So fumigating, so when there is inversion over super adiabatic, you will be having fumigating plume. So we will be having fumigating plume, and fanning plume. So you will be having fanning plume when inversion is there. So here it is 1, 2, 3, 4. When it is adiabatic, we will be having a coning plume. Okay, when it is adiabatic, we will be having coning plume. So P1, Q2, R3 and S4 is the answer. 1, 2, 3, 4 is the answer. So option A is the answer. It is question number 17. Question number 17. Option A is the answer. Option A is the answer. So we will do one thing. We will discuss the rest of the questions in the next session. So I am concluding this session. Thank you so much.